All right, in this exercise, we're going to keep building off our growth nutrients 1 code last time, which I have loaded up here. I'm going to go ahead and save it as growth nutrients 2 code. So we can recover that if necessary. And it's going to be largely the same. We're not going to do as many modifications as we did last time. So we're also going to be adding a nutrient field and computing growth rates, and in this version, the nutrients will have a seasonal signal. All right, how are we going to do that? All right, well, first of all, we're going to come down and copy our light data in, have it read in. So there it is. There's our 10 years of light data. And then last time we did this mixed layer depth index where we just repeated 40 the same time, basically for 10 years. So the mixed layer depth didn't change. So this is the major thing that we're going to change here. So I'm just going to put a comment by this and just make a new one. So MLD end. So we need to give this a seasonal representation. So what we're going to do is create an oscillating function, and we want that oscillating function to also have some noise in it. And so we're going to, oh, it looks like I lost my, yeah, I should put this back. We're going to use a function called rnorm. All right, rnorm. And before we go any further, we're going to do question mark here, rnorm. We'll do a little lesson on rnorm here. So rnorm is the normal distribution, and we're looking at this one here. So n, the argument n, is the number of observations that you want. The mean is a vector of means, or a mean, what mean you want the normal distribution to have. And the SD is the vector of standard deviation. So before we go ahead and use it here, let's mess around with rnorm here a little bit. So if we say we want to rnorm 100 observations, that's what our n is. We want them to have a mean equals 0, and we want them to have a standard deviation equal to 1. What does that produce? If I do that and I run that, it just produces a whole bunch of numbers, whole bunch. All right. Those are random numbers with a mean of 0, standard deviation of 1. And we can see that if we do a histogram, HIST, around this. Let's go ahead and now produce that. And you'll see that. Here's the frequency. It looks like we have a normal distribution here of about 100 numbers, mean of 0, standard deviation of 1. We can make that even clearer if we bump this up to, say, like 1,000 numbers. Right, okay, so we have a nice even distribution, and we can change the standard deviation. We can say, well, we want our standard deviation to be a little bit wider. So here it's going out to 3 and -3. Now it's going out to 6 and -6, so we can make that much wider or narrower. We can also change the mean. Let's say we want to have a mean of 20. Then we run that. Our mean is going to be around 20. We have 1,000 variates, each with a mean of 20, standard deviation of 1. That's what the description of that distribution. We can do something interesting here with this, which before what we did is we just repeated 40 times the length of sun time. So we produced a whole bunch of values, the length of sun time, and we know what the length of sun time is 3,653. So if we put in here the length of sun time, all right, this is going to produce 3,653 values with a mean of 20, standard deviation of 1. Okay, what happens if we have standard deviation of 0? This now is going to produce 3,653 with a mean of 20, standard deviation of 0. That is just going to be repeating values of 20. There's 20 here. You can probably see it better if I just run this. 20, 20, 20, 20 all over again, and I can change it to 40. And if I change this to 40, I'm going to get a big long vector, a length of sun time of 40, which is doing exactly the same thing as this, repeating 40 times the length of sun time. So we're just using a different function, a random number generator, which may be a little bit weird for you to think about, that it's a random number generator, but random number generators with standard deviations of 0 produce the same number over and over and over again. But we're going to show you how we're going to use this here in just a little bit. So let me go ahead and take this out, our norm. Now another thing we can do is actually make this mean value here a function. So it's not always at 40. We're going to actually have this thing change a little bit through time. We're going to have it change according to a cosine pattern, which is a very common seasonal pattern. So down here below, we're going to start with something else here. Let's do generate a sequence of numbers from 0 to 2 pi. 0 to 2, so I got to do 2 times pi. And we want the length of those to equal sun time. Right? So if you do a sequence from 0 to 2 pi, what are we going to get? Well, let's go ahead and plot that. Zero to 2 pi, okay, 0 to 2 pi, right? 6.28, and the length of is sun time. And what I'm going to do now is take the negative cosine of this thing, of this sequence. Now let's go ahead and plot it. Okay, so why do we have a negative cosine? Well, negative cosine usually goes from 1 to 0 back to 1. We're going to make it a negative, so our lowest values are in the beginning of our time series. So that would be like, in July or June. I'm sorry, January. This would be in July. But this is, we have 10 years of time slots in here, but we only have one cycle. That's because 2 pi is one cycle. So if we're going to do 10 years, we're going to have to change this to 20 pi. So that's 2 pi per year. And we're going to get an index now that's oscillating every year from -1 to 1. In fact, we can plot sun time and then this cosine thing. And you'll see that we now have this oscillating index that's going back and forth. So what else do we want to do? We want to increase the amplitude of this thing. So I'm going to do 30 times this. Let's see where the cosine. Yeah, okay. 30 times that thing. Let's run that. Okay, that looks pretty good. And then what I'm going to do here then is, well, before I do the 30 cosine, before I do this, so I don't want to have negative values going back and forth. So let me take this out. Let's plot this. And it goes from -1 to 1. But what I really want to do is have this thing be all positive. So if I add 1 here on this inner parentheses, I think, will this work? Let me see. So now if I do it, all of my values are positive. That's good. And then I'm going to do 30 times that. Okay. Oh, that didn't work. Do a parentheses here, do an extra parentheses. There we go. Going from 0 to 60 now. Going from 0 to 60. That's oscillating. Okay. So this thing, this sun time, now generates, this thing here, starting with this 30, this function, now generates oscillating values. So if I stick this thing in place of this mean equals 40, this is now going to be the mean of a distribution, and I plot that. Let's take this out of the way. Equals R norm. Okay. We plot the MLD index. Okay, now we have an index that's oscillating, right? So this is now going to go into our equation for computing nutrient fields, and we can add noise to it. So let's do standard deviation of 2. We can make it noisy. We can make it even more. We can add a standard deviation of 20. Run. There it is. So this would be a mixed layer depth with some noise added in it. Let's stick with 0 for now. So if we do that, and now we just create our nutrient field with our existing code, see what happens. Okay, now we have a nutrient field with an oscillating mix layer, and you can see here that our mix layer is decreasing and then increasing and decreasing and increasing and going up and down seasonally. So during the wintertime, all the nutrients are up, they're mixed up at the surface, and during the summertime, they're low. They're low and stratified. And so now that we have this, we can go ahead and run our entire simulation and see what happens. So let's go ahead and do that. And just grab the rest of it, copy everything down all the way to the very end where we see cell field, and run. So all we've done here is add the oscillating mix layer, and we want to see how that changes the system. So now it's going to go through and make all of our plots. Okay, so once we see it here, so this is the last plot that was made, we can scroll back through. So that's cell fields. Push back, should go back to growth rates, and so on and so forth. So different things are happening here. And so the other thing to try is to come all the way back up to the top. I'll go ahead and we can just do remove the list. Come all the way back up to the top of your code, where you see that mix layer depth. Oh, we should take this out. We don't need that. And make our standard deviation, I don't know, make it bigger. Make it 20. And go ahead and rerun everything and see how that changes the system. Oh boy. Yeah, that's not good because I didn't copy from the top. So there's our variable mixed layer depth. So you can see our nutrient field is quite a bit different now. Okay, see how the cell field has changed quite a bit. And of course you can scroll back through here to look at previous plots where you can remake them individually here from this code. But from here on out, I'll point you to the homework.